Hello, Michael Collins here to talk to you today about using the Microlab FS522 laboratory interface in conjunction with the pH electrode in order to do a titration. In this particular video, what I'm going to show you is how to do a calibration using standard pH buffers. Here's a photograph of the setup that I'm using. On the left, I have a Windows 7 laptop connected through a USB port to the Microlab FS522 laboratory interface. In the front panel, you can see that I've got connected to the laboratory interface a pH electrode. This is a standard combination pH electrode with a VNC connector, and again that's plugged into the pH redox dissolved oxygen port on the Microlab interface. I also have Microlab's patented drop counter plugged into the counter jack on the front panel of the FS522. I'll get to the rest of this later in a different video when we actually do the titration. In addition to the lab interface and the pH electrode, I have three commercial buffers, pH 4, pH 7, and pH 10. One of the unique features of Microlab's calibration interface is that you can use as many references as you want. I suppose you could use buffers from pH 1 to 14 if you wanted to. I'm going to do a three pH calibration today. So let's just get rid of this, and we're going to go to the Microlab software. We'll open the software. You can see the blue bar as usual indicating communication with the laboratory interface. The Microlab experiment that we're going to build today is a pH experiment. So for purposes of this video, I'm just going to add the pH sensor. In the subsequent video when we do the titration, I will also be adding the counter sensor. So we'll just do the calibration in this video. So click on Add Sensor. Click on the down arrow to bring up the sensor drop-down dialog. I'm going to click on pH dissolved oxygen. Notice the black square or the red square around the proper jack on the cartoon of the front panel. I'm going to click on that. That's going to activate the sensor I'm going to choose. In this case, it's a pH sensor. Notice when I click on that, I also get the pH label showing up in the interface dialog box. Click Next. We're going to perform a new calibration. Here's the window. Now notice we'll add a calibration point. We'll also be able later on, when we have the points, to choose the type of fit we want. Linear, second order, single point, whatever. Okay, so let's add a calibration point. I'm going to now take the electrode out of the deionized water solution that it was resting in and place it into a stirred pH 4 buffer. Notice the graphical rendering that we're getting here. I'm going to type 4 into the actual value, and then we're going to just wait for this to stabilize. You can see the measured value 0.126 still changing a bit. We have a graphical rendering of the rate of change, and we have a meter that's sort of like a galvanometer meter that shows you kind of the comings and goings. So for the purposes of the demonstration, let's just leave it at that and say that's good enough. Okay. So now I have a pH 4 point. I'm treating the electrode as usual. I'm placing it back into deionized water and then wiping it off before I put it into the next buffer solution. So I'm going to move to pH 7, begin that stirring on the magnetic stirrer, and then we're going to click on Add a Calibration Point. Again, I'm taking it out, wiping it off, and then replacing it into the pH 7 buffer. Notice the rapid change means it's a good electrode. It also should change by about 180 millivolts since it's a 3 pH change. And I'm going to type 7 in there. I could put in 7.00, whatever you want. And again, this is probably close enough for the demonstration purposes. So I'm going to say OK. We have a second point. At this point, we could actually put in a first order linear fit, but I'm going to add a third point pH 10 before I do the fit. So here we have it in the pH 10 buffer. Again, notice the rapid change. And for the purposes of the demonstration, I'm going to say OK. There we have it. We have 3 calibration points. We still have no fit. I'm going to do a linear fit. Let's see how that works. When we do the linear fit, you can see down below here, we have the actual value from the hardware. Ranges from about minus 0.22 volts up to about 0.13 volts. We have a rate of change. Oh, the actual value is the millivolts, and the calibrated value are the pH readings. So our rate of change is about 17 pH units per volt. There we have it. This is our calibration line. I'm going to accept and save this. We'll save it as a pH unit, and I'm going to save it as a new value for my pH calibration, or I could type in any value I want down here. Yes, I want to replace it, even though it already exists, and now we can finish. So here we have our calibrated pH electrode. I'm going to drag this over, click and drag to the digital display. I'm going to put this back into the pH 10 buffer. There we go. I'm going to rinse it, place it into the pH 4 buffer after I wipe it off. And it appears as though we have a good functioning electrode. Again, for the purposes of this demonstration, what we've done in just a couple of minutes is a 3-point calibration of a pH electrode, and at this point we are ready to do a titration. Thanks for watching.